Hello friends, in this video I will cover about split size, which is a very important tuning technique when you to tune your MapReduce applications. Okay, for this I will be using dataset called large deck, and data will look like this. It will be 2 GB size of data, which will have the color, sweet and pip of deck of cards. So I have produced a 2 GB file. I have produced a 2 GB file using the deck of cards, which have millions of records similar to that, color, sweet and pip. Okay, and the replication factor I have used for this file is 2, and the block size is 128 MB. So if you click on this, you can get the details of all the blocks of that file. There are 17 blocks because the block size is 128 MB. Approximately 2 GB file is divided into 17 blocks. To get the details of all the blocks in one shot, you can run a command called hdfs-fsck. You can give the path of the file, in this case user hd user largedeck.txt, and you have to specify files, blocks and locations, and it will give all the blocks and the size of each block and where it actually resides based upon the replication factor. So in this case, all the 17 blocks are replicated twice. So approximately each node will have around 600 MB of data. Okay, so that is about the data I will be using. Now I will explain it to you about the code. So I have created a new application called performance tuning, which will be used to showcase all possible performance tuning techniques using code, which I have shown in the list. And there is a program called rowcount.java card count by pip for now, but I will add more as we progress in this. And this performance tuning package will be uploaded in GitHub, and the location will be, if you go to github.com/durga gadiraju, you will see multiple repositories, one for data and one for code, and the code will have the performance tuning jar file as well. Performance tuning source code as well. For now I just have getting started, but eventually I will add performance tuning as well. So that is about data and code. Now we will actually get into the actual topic, split size. First you need to understand what is a split size. As you are familiar with HDFS, a file will be divided into multiple blocks depending upon the block size. And to explain about split size, I have already ran a MapReduce job from that performance tuning.jar. I have used the row count program, and I have passed the large deck.txt as the input file, and output large deck.splitSize01 as the output file. Okay, and if you once you hit enter, first one of the information you will see immediately is number of splits. So these number of splits will be typically equal to number of blocks in the number of blocks in the file. So in this case, our number of blocks in the file is 17, and the number of splits are also equal to 17. That is because the split size and block size are by default same. Okay, and then if you scroll down and if you start looking into the counters information, then it will explain how many map tasks are used. So this the number of map tasks will be equivalent to number of split size by default, unless there is JVM reuse and other some advanced features that have triggered, but typically they will be same. Number of splits, number of blocks and launched map tasks will be same. So what is the side effect of using 17 mappers in this case? In this case we have 2 GB worth of data, and each it's a 3 node cluster. Let me show you details about my cluster in Cloudera Manager. So in Cloud Data Manager, if you click on horse, it will give the details of your cluster. So in my case, if you click on roles, you will understand what each role is, what each node is doing. And also you can go to your name node UI, and you can click on data nodes, and it will list you your data nodes. In my case, 240, 241 and 242 are my data nodes. Okay, so as I have 3 node cluster, the 2 GB file will be approximately divided into means each node will have approximately 700 MB of data. Okay, but if you are familiar with the MapReduce workflow, when you enter the job, depending upon the number of map tasks, a JVM will be forked, and it will process the data, and then it will be killed. So when data is densely located on multiple nodes in the cluster, if you can reduce the number of map tasks to process the data, the performance can be better in multiple ways. It will save time on creating a new JVM for each and every block and killing the JVM after processing is done. So the creation and killing of JVMs will be reduced, as we will be using fewer number of mappers. And second, it will make room for other MapReduce jobs to run. In this case, let's say the capacity of my cluster is to run 20 mappers at any given point in time, and capacity of your cluster to run map tasks and reduce tasks will be determined by the memory available and the number of processes available, and several other factors. Based upon that, the capacity will be determined. In this video, I will not be explaining you how that will be done, but for a hypothetical scenario, let us say that the capacity of your cluster is 20 mappers at any given point in time, or 20 tasks at any given point in time. So in this case, when you run this job, it already taken 17, and if there is some other job that is launched which requires 10 or whatever number of mappers to complete, only 3 will be given until the map tasks that are launched by this MapReduce job start completing. So others will be in queue. So what I'm trying to say is, by reducing the number of map tasks, even though the execution time might extend a little bit for this job, but it will make room for other jobs. So your resources will be effectively used. So I have covered 2 scenarios so far. First of all, this MapReduce job can be faster by reducing the number of map tasks, because the creation and killing of JVMs will be reduced, because we are using fewer JVMs by reducing the number of map tasks. And second, this can make room for other jobs to run more to run along with this, and the resources in the cluster can be effectively used when you actually reduce the number of map tasks. So that is the advantage which you will get. Now we will determine how to reduce the map tasks. So the primary thing which you need to which you need to keep in mind to reduce the map tasks is a parameter which defines the minimum split size. Now let us see how we can explore and get the details of the split size. Okay, we already ran a job, and when we ran the job, typically if you are using Yarn, you will find this URL for each job, and you can copy this, and you can go open your UI. You can open your browser, and then you can once the job logs are provided on UI, you can click there will be a link on left called configuration. You can click on this, and then you can search for split dot min size. So this will determine your number of map tasks. How it will determine? By default it is 0, which means that the split min size is equal to the block size. If it is 0, the min size and the split min size and block size are same. So we will tweak this and try to run this, run a MapReduce program and see how it will perform. Okay. So one of the easiest way to play with these parameters is by using a uh, by using a command line predefined parameter called -d, and then uh, you can pass your parameter whatever you want to tweak as while you run the program, and you can give the split size. Okay, so in this case I have given 256 MB. I didn't make any change to the code. I am just adding this -d parameter to the runtime command to run our program using Hadoop jar, and also I have to rename the directory because I'm not handling gracefully. If the directory already exists, it will fail. So I'm rerunning using a different output directory name with a different split min size. Now if you see, number of splits are 9. Okay, now once this is executed, we can compare this output, the counters that are provided here with the counters that will be provided here, and we will see the performance. I am sorry for that. Okay, so the job is completed with split size 256 MB, and I have copied the matrix to here so that we can compare the counters of the old job and the counters of the new job. And the most important thing you need to watch is the job counters. So job counters with 256 MB, it is using less map tasks. All the map tasks are local, so that is a good sign. If few of the map tasks are not local, that means data might not be densely spread across the nodes in the cluster. So it has to copy some data over the network from other nodes, which is not a good sign, and it can cause some performance issues. But as long as this one and this one launched map tasks and data local map tasks are same, we are good. And then you can look at all the time spent by all maps, time spent metrics in both the cases. All the times this one is better than this one. The reason is it has used lesser JVMs, so the time taken in this case to create the JVMs and kill the JVMs is lesser than the original one. So overall the performance is better, and you can even look at the execution time. So here it completed at 6:02:34 and it started at 5:58:13. So it took almost 4 minutes 21 seconds. In this case it took almost 41:20 to 46:45. So it almost took 5 minutes 25 seconds, and this took only 4 minutes 21 seconds. Sometimes as you are using more mappers in the previous job, it can perform better, but you should not only rely on the time, you have to look at all the other metrics. That's why I started comparing with this one. You have to compare these two things, and you need to on a fully loaded cluster, even though the jobs that uses higher split size might be performing a little bit slower, but as it shares resources with others more gracefully, increasing split size might be a better option than running with lower split size. And to determine the ideal split size, you can play around, but you need to keep certain things in mind before increasing the split size to a much higher value. And that one is there is a parameter called IO sort MB, and the split size should not go beyond 50% of the IO sort MB as a general thumb rule. In some cases, if you have better understanding about the internals of Hadoop, you can increase it, but typically you should not go beyond 50% of this. In this case, it is 256 MB, but I have increased to 256 and the split size to 256 MB, but still it performed okay. But in some cases, you will run into out of memory issues. So on a bigger clusters, typically this will be on production clusters. Typically, it will be either 1 GB or 2 GB. Based upon the IO sort MB, you can increase your split size up to a certain value where you will not start running into out of memory issues. Okay, being said that, now I will explain how to specify split size when you run the jobs. There are multiple ways. One of the way is to specify it in Hadoop jar command by using -d parameter, and you can pass any parameter which you want to override. Okay, this is one way to increase the split size. And then second way is in your program. You can tweak your program. So let me go to the row count program, and here you can set split size to, there is a method under job class, set okay, set min. What? Yeah, actually you can do this job dot set, and then you can, so this is another approach. Actually I have to use configuration. So what I have to do is I have to create a configuration object. That is fine. So once you do that, you can, there is a method called set, and here you can specify. So you have to create a configuration object, and then you have to set your parameters. So in this case, let me do this. Okay, and then what you have to do is you have to move this to here, and then you have to give, so this is the second way of doing it. You can even set the parameter as part of your programs. And then if you are using Hive, you have to so if you launch Hive, first we will see what is the default parameter in Hive. First split, what is the default split size in your Hive parameters, and then we will see how to tweak it in Hive. So in Hive, the min size is set to 256 MB already. If you want to reset to a higher value, you can launch your command line, and then under Hive command line interface, you can actually use the set command like this, and then you can set to whatever size you want. And then if you run the query, as you might have already aware, Hive will convert the queries into MapReduce jobs, and it will pass these parameters as a configuration change to the job, and this one will be used to determine number of mappers as part of your Hive queries. So this is how you can set the min split size, and you can tweak the performance to reduce the number of mappers. So that is it about the split size. I hope you enjoy this session. See you soon.